minus 6 like this.
Okay.
Okay, and then another way to write this here is to write it as x minus 6 squared.
Squared. Okay. All right. Yeah. Makes sense. Okay. So let's do another easy problem. 14. Are you there? 14 x squared minus 9y squared.
Like this.
Mm-hmm.
Are you sure? This doesn't seem right here.
Let me.
So is that what it,
Oh, it's 16. My bad.
Okay. Okay, so this is a difference of squares problem. I can't remember if we did that last time, but you try to rewrite it as something squared minus something squared.
Mhm.
Does that at all look familiar?
Sort of. I don't think we did it last time. We did greatest common factor, perfect square. Then we did
Okay.
a equals 1 and something like that.
Got it. So what square gets you back to 16?
That would be 8.
So 8 squared is 64. 8 times 8 is 64.
8 times 8. That would be, say 4. Yeah, 4.
4 is good. And then the x gets you back to x squared. So notice when you square 4, you get 16. When you square x, you get x squared.
Okay, I remember something like this. Yeah.
Now we do the same thing on the right here. What do you square to get back to 9?
1? Would 1 count?
1 squared is 1.
Oh, 1 squared. So then 9.
9 squared is 81.
Oh.
So a number times itself that gets you back to 9.
Oh, 3.
3. Perfect. Yeah. So there's a list, right? Like there's a bunch of these that you are supposed to know. 3 it works for 9, and then the y gets you back to 2y squared.
Mhm.
Now I'm going to write this. I'm going to write the formula below it. In your problem, a is 4x and b is 3y. So the a is everything that's inside parentheses. The b is everything inside parentheses. That's a minus b, a plus b. So in your problem, you're going to write, you will write the thing that's inside parentheses. 4x minus 3y, 4x plus 3y.
Okay. It's pretty simple. Okay. All right. So let's do another problem. M squared minus M4 minus 12.
Like this.
Mm-hmm.
So it's odd that the 4 is here. It should be usually be
My
over
bad.
here.
It would be 4, the bigger number 4.
Okay.
4M.
M to the 4th or 4m.
4M.
Okay, and then m squared like this.
Mm-hmm. Yes.
Okay, so this is considered higher order factoring.
I'm sorry. I know it's my mistake, but it would be M squared minus 4M.
Okay,
I know it's my bad.
it's okay. All right, m squared minus 4m minus 12. Okay. All right, and this is not higher order factoring. This is something else. This is a equals 1, meaning there's a 1 in front of the m squared. Okay.
Okay.
All right, so the way you do this is you find all the numbers that multiply to negative 12, but add to negative 4. Okay. Why don't you give this a try, coming up with a list or telling me which numbers multiply to negative 12, but they have to also add to negative 4.
Okay. B. That would be
How's it going, Josh?
so I found a couple. I found 1 and 12, 3 and 4. Oh, I missed yeah, and then 6 and 6.
So yeah, so 6 and 6, remember they've got to multiply. So
These 2 and 6.
yeah, 2 and 6 here. And the order doesn't really matter, but you want to get them all. So sometimes it's good to go sort of an ascending order like that. Okay. And then do any of these add up to -4? Any in this list on the right here, do they add up to -4?
I would say, if I'm thinking, because negatives, I would say -2 and 6.
That adds up to +4.
+4. So then it would be 2 and -6.
Yes, yes. Okay, so really the hardest part is coming up with the list. So in this case, it's m plus 2. Notice I'm using that number on the right there, and then
Mhm.
m minus 6.
Okay. Okay.
All right, so whenever you're ready, go ahead and give me that next one you want us to work on.
4x squared minus 11x minus 3.
Like this?
Yes.
Okay, very good. So this is the a not equal to 1, and this is a grouping problem. Okay, I know that because the first number in front of x squared is not 1, it's a 4. Okay, and the 4 doesn't factor out, it's not a GCF. Okay, so this one's different. I don't know if we've done this one yet. You start by taking the 4 and multiplying it by the minus 3. So you come off to the right here, 4 times -3, that's -12. Okay, then you have to make a list like we've been doing.
Okay.
-1 and 12, 1 and -12, -2 and 6, 2 and -6. Notice there's kind of a pattern to the way I'm doing this. -3 and 4, 3 and -4. So you keep going until you kind of wrap around on this list. Now, where are we going with this? You're looking for the one that adds up to -11. So you build this list on the right, and then you want the one that adds up to -11.
Okay.
Okay, which one would that be?
1 and -12.
Yes, it's this one here. Now you've got a choice, and this is where I think it may be more challenging. You're splitting apart this -11x. Okay, so you can
Correct.
either write x minus 12x or -12x plus 4. And you might be like, well, what's the difference? So let me bring the other terms down. So here's what you're going to do next. You're going to factor the GCF out of the first two. So it looks like the second one is better. See how -12x pairs a little better with 4x squared?
Yes.
Okay, and that's kind of how you make your choice. So we're going to not use that one. We're going to use the second one. What is the GCF between 4x squared and -12x?
I would say
What's the number that goes into both? And then what's the smallest variable exponent?
the 2,
A little bigger.
then 3.
4. 4 goes into
4.
both.
Okay.
4 goes in both 4 and 12. Now between x squared and x, what is the smallest exponent?
X.
X. Okay. So now you're going to divide each of those by 4x.
Okay, that would be x and then minus 4
3.
3, and then
Yes.
I would say that's it.
Okay, very good. Yeah, so I kind of miswrote this here. So now you take what's inside parentheses and you immediately write it over here to the right.
Okay.
Okay, so you get what's in parentheses, you're like, all right, let me move it over here. And then you're trying to figure out what goes in sort of this empty position here, such that when you multiply in to x and minus 3, you get back to the previous line.
Okay.
Okay, and this time I'll just give you the answer. It's +1, because 1 times x gives you x, 1 times minus 3 gives you -3.
Oh, okay.
Okay. All right. So now we're not done. Like, it feels like, wait, we've done all this work. Yeah, we have. We've done a ton of work. Do you see that there's an x minus 3 in both of these?
Yes.
So you can actually factor that out again. I like to call this double factoring. They call it grouping, but you're actually factoring twice.
Okay.
So what is left over is the 4x and then the +1.
Mhm.
And now it is done. Now it is complete.
Okay. Wow.
So there's
That's a lot of work.
quite a bit to do here. So obviously it'd be good for us to do a few more of those
Mhm.
if needed.
Okay. I would say let's try one of these problems. I think it might be the same
Okay.
as the one we just did, but maybe not. Most likely not. But 2x squared plus 5xy plus 2y squared.
Okay. So yeah, it is similar. We're gonna ignore the y for the moment. We're gonna
Okay.
actually write it without the y.
Okay.
Is that okay?
Yeah.
All right. Now we're gonna do the same thing we did in the previous problem. We're gonna take that first number, multiply it by the last. Okay, so that's 2 times 2, which is 4. So now we're looking for two numbers that multiply to 4, but add up to 5.
Okay.
What is the result of that?
Be 1 plus 4.
1 plus 4. So again, we kind of have this option here. We can write plus 4x plus 1x, which I think is better because the 4 pairs better with the 2, or we could switch the order here. Okay.
I would just say keep it like that.
Yeah, keep it like that is good. Okay. And we'll deal with that y in a moment, but for now, you've got to find the GCF between these first two. Can you tell me what that is?
2.
2 is the number. What about the variable? 2 what?
2x.
2x. Okay. And so you're going to divide each of these by 2x. So tell me what goes in parentheses.
X and 2.
Plus 2.
X
Good.
plus
And then you immediately write it over here.
2. Mhm.
Okay. And then you figure out, well, what goes in this position such that when you multiply in, you get back to the previous line. And do you see how it's the same?
Yes.
What number do you multiply by to get the same thing? No
1.
change. 1. So +1. Okay. And then it's double factoring, so you end up factoring in here. It's x plus 2 times 2x plus 1. Okay. And you might think, hey, like I've done it, right? One little change. Like, remember how we took that y out at the beginning?
Yep.
We have to add it back in. So it always pairs into the end here. It becomes 2y plus 1y.
Okay.
Okay, now that's a little bit of a shortcut here. I mean, that's not really the official way to do it, but I found for most students, it's better to tell them to, hey, just ignore it and then put it in at the end.
Mhm.
Is that okay with you?
Yeah. Yeah, that's fine. Easier. Okay. So let's do a different problem. I think this would be
Sure.
a equals 1. This is what it looks like.
We'll see. Yep.
X squared plus 2ax minus 3a squared.
Like this.
Mm-hmm.
Okay, so again, we're gonna eliminate the second variable, eliminate a.
Okay.
So look at this as x squared plus 2x minus 3.
Okay.
Okay, so now you're looking for two numbers that multiply to -3, but add to +2. It is like you said, it's an A equals 1 type in this So can you come up with those two numbers that multiply to -3 but add to +2?
I would say the 1 and then -3.
So these add to -2. 1 plus -3 is -2.
Okay.
So what's the other way around? What's the flip of the signs?
-1 and 3.
+3. Good. So that becomes +2.
Okay. Okay.
Okay,
There you
so we would write x minus 1, x plus 3.
go. Mhm.
Is that okay? Is that clear?
Yes.
Now where should the a go? We can't forget about the a. What did we do
Mhm.
in the last problem with that letter?
We put it at the end, so it would be 1A and then 3A.
Yes, and that is it. So whenever you
Okay.
see a second variable, you can eliminate it for now and then add it back in.
What would happen to the squared, A squared?
So the answer to your question is if we were to FOIL this, the L, you remember FOIL? L is the last times the last.
Yeah.
1A times 3A gives you the 3A squared.
Oh, okay.
So it does work itself out. It's just that it's, maybe it's uncomfortable because it's like,
Mhm.
how come we can just remove it?
Yeah.
I agree. It's a little bit of smoke and mirrors magic, if you believe in that sort of thing. But it's to make the problem easier. In math, you almost always convert something you don't know into something you do know and work it out that way.
Mhm. Okay. So more problems. Grab here. Okay. All right. So 12 AB
Okay.
squared minus 18A squared B.
Like this.
Mm-hmm.
Okay. All right. So two terms here, right?
Uh-huh.
First term, second term. So here are our options. It can either be a GCF or it's a difference of squares. What do you think? What kind of stands out to you here?
Let's say GCF.
It is a GCF. Yes.
Yes.
So we're going to look at the numbers first. What is the largest number that goes into 12 and 18?
That would be 4.
A little bigger. 4 does not go into 18.
4 does not. Okay. So 6.
6 is good. Now, is there an A in both?
Yes. So be
Okay.
just A.
Just A. And is there a B in both?
Yes. So it would just be B.
Okay, so you're going to divide each of those by 6AB, 6AB. So go ahead and let me know what you come up with when you work that out.
Would be 2B minus what would that be? It would be 2 A, and that's it.
That is it. Now, there's a small mistake on the second one. What is 18 divided by 6?
Oh, that would be 3.
You got it. There you go.
Okay. All right. I'm just editing the problem. Okay. So we forgot this was A equals 1. So it would be, are you ready?
Yep.
M squared minus 8M plus 16.
Like this?
Mm-hmm.
Okay, very good. This is an A equals 1, but it's also a perfect square trinomial.
Okay. both.
And you find that out, like if you don't recognize it's a perfect square trinomial, when you do the a equals 1, which is looking at 16 and trying to find two numbers that multiply to 16 but add to -8, you will find out that it is a perfect square trinomial. All right, so to kind of give clarity to that, I want you to find the two numbers that multiply to 16 but add to -8.
Okay. B. Okay, so that would be -2 times 8. Would be
That, so,
-2 plus 8.
well, okay, so this does not multiply to 16, it multiplies to -16.
Okay.
So it for example, so -2 times -8 is 16, but does that add to -8?
No.
Okay, so you got to find another one on the list.
Okay, it would be 4 plus 4.
4 and 4 do multiply to 16, but they don't add to -8. They add to +8.
I would say one of them would be negative.
They have to both be negative.
Both be negative.
The only way you can get to a positive is if they're both negative.
So that would be 16 and 8. Okay.
So this becomes m minus 4, m minus 4. Now, remember I mentioned that you might recognize why this is a perfect square trinomial. Do you see that these are both the same?
Yes.
They're duplicates.
Yeah.
That's why it's a perfect square trinomial. That's one reason.
Okay. Yeah. Both m minus 1, m minus 4. Okay.
Okay. Now, again, the other thing is that you could write m minus 4 squared because they're exactly the same.
Okay. Okay. So get a different problem out. All right. It would, all right, I'm going to read it out loud again.
Okay.
3x squared plus 30x plus 75.
Like this.
Mm-hmm.
Okay. This is a good time to write out all the factorings. GCF, difference of squares, perfect square trinomial, a equals 1, a not equal to 1, which is grouping. You should always start with GCF. Always, always, always. Is there a number or a variable that goes into all three of these? And your focus should really be on that 3.
Okay. I don't think so.
Is 30 divisible by 3?
Yes.
Yes, it is. How about 75? That's the last one. And if you're allowed to use a calculator, again, I'm not anti-calculator. You can use whatever you think would be best to help you today.
It would be, yes.
It is. You're going to factor 3 out of each. So can you give me what goes inside parentheses here, please?
That would be 2x with
Nope.
2 squared.
X squared.
X
Just
squared
plus.
plus 10x.
Good.
Plus 25.
Very good. Okay. Now, this isn't a equals 1, but it actually is also a perfect square trinomial. And the reason I know that is because you can take the square root of the last term here. Okay, now it's not always a perfect square trinomial, but that is a good indicator of it. So I want you to find two numbers that multiply to 25, but add to positive 10.
Ooh, okay. Okay, it would be 5 and 5.
5 and 5. So this becomes x plus 5, x plus 5, bring the 3 down. And then if you want, you can combine them, x plus 5 squared, like
Mhm.
that.
Oh, wow. Okay. So, all right. Now, oof, yeah. Okay. All right. It's a short problem,
Okay,
and this would be a equals 1. X cubed minus 16x.
like this.
Mm-hmm.
Okay, so if there's two terms, there's only two possibilities, GCF, difference of squares.
Okay.
Okay, they could, GCF could have more than two terms, but it's only these two. Is there a number or a letter that goes into both of these?
X.
X. So I want you to tell me what goes inside parentheses after you factor an X out.
Say x squared
Okay, minus,
minus 16.
good. All right, so this inside parentheses is in fact difference of squares. Okay, so just like we talked about before, you have to figure out what squared gets you back to x squared minus what squared gets you back to 16. And it's usually easiest to start with the number.
Would be the number would be 4,
Or good.
and then I guess x.
Yes. Now, I wrote the formula before. It's always good to write it each time you're going to use it here. So A is whatever's inside parentheses here. B is whatever's inside parentheses here. And you write A minus B, A plus B. So tell me what I would write here off to the side.
You would write it would be x minus 4 and then x plus 4.
Good. Now, just to keep in mind here, that is only the part that's inside parentheses. Okay. Your final answer is kind of like you're combining synthesis of these. So it's x times x minus 4, x plus 4.
Could it be x and then x minus 4 squared?
No, because they're not the same.
No.
They'd have to be exactly
Okay.
the same.
Oh, yeah.
So in the previous problem, it was x plus 5, x plus 5. They're exactly the same.
All right. All right. So, do a longer one. Are you ready?
Sure.
3x squared plus 21x minus 36.
Like this.
Yes.
Okay. What's the very first type of factoring that you should always try?
By the biggest number,
Nope. What's it called? What's the name of it?
greatest common factor.
GCF. Yeah. Now, is there a number or a letter that goes in all three? You should always try the first number there.
Okay, so that was could be 3.
It would be 3.
Be
So
3.
so what goes in parentheses here?
X squared plus 7x minus 12.
Okay, very good. Now this is an A equals 1 type problem.
Okay. Okay.
So negative 12, two numbers that multiply to negative 12 but add to positive 7.
Okay. That would be
Well, let's just go through it together. Negative 1 and 12, 1 and negative 12, negative 2 and 6, 2 and negative 6, negative 3 and 4, 3 and negative 4. Do any of these add perfectly to 7?
I would say no, but I would say -3 and 4.
That adds to +1.
Oh, okay, so then it would be 3 and -4.
This adds to -1.
Oh,
So it looks like it, right? It looks like this factors.
yeah. Oh. Hmm.
So sometimes it doesn't. So this is the answer. Now, just to be clear, is this exactly the way it was written? 3x squared plus 21x minus 36?
Mhm. Yep.
Okay.
Yeah. Exactly. Okay. Okay. Okay, well, x squared minus 8x minus 20.
Like this?
Yes.
Okay. So this is an a equals 1. There's a 1 in front of the x squared. So you're looking for two numbers that multiply to -20, but add to -8. So I want you to try this one on your own. See if you can come up with those two numbers that they have to multiply to -20 and then add to -8.
Okay. Okay, so we'll do the first one. Would be 2, 10, 3 times 3 times 3. No, no. Okay. 5, 5, 4, 6. I'm not really finding anything that would.
Okay, so it's -1 times what number gets you to -20?
-1 and 20.
20. And then you flip the signs. Okay. All right. So neither of those work, but that's okay. -2 times what gets you to
10.
-10. And then you flip the signs. Do either of those work?
Mm, actually, yes.
Now,
It would be.
did you write it and you didn't see that it added up, or did you just not write it all together?
I wrote on this piece of paper 1 and 20, 2, 10, 4 and 5, and 5 and 4.
But none of those that you wrote down multiply to -20 because one has to be negative, one has to be positive.
Okay. So if I do this, then I would say it would be 2 and -10.
Okay, so what do you write over here on the left?
That would be x squared.
Nope, no x.
No,
No
no
x
x
squared. No
squared.
x squared because we haven't written an x squared in any of the factoring that we've done. After when you break it apart into two, it's always x and x to the power of 1.
So it would be x, just x minus. Trying to think. I think I have some problems here. It would be x. My brain.
Let's go back and look at one that we did already, like
Okay.
this. Okay, because you were able to do it here. You go find one here. All right, so here we go. Right, right, it's not a good example. Let's go right back to this one here. So it was -6, -6. Right?
Okay.
And then you wrote x -6, -6. So whatever pair works, that's what you put in parentheses. Okay.
Oh,
We
okay.
did the same thing here. 2 and -6 works. 2 and -6 works. So it's m plus 2, m minus 6. See how it's 2 and -6? Whatever numbers work, that's what goes in parentheses.
Oh, okay.
Okay. So here we
Okay.
go. What goes in parentheses here?
-2 x.
But we didn't choose -2. We chose +2.
Oh, well, I was thinking of that negative in front of 8, but
But you're looking for two numbers that add together to get -8. Do you have those two numbers here?
yes.
So you write them here, 2 and -10.
Mhm. Okay. Okay, now I'm figuring it out.
Okay, we got a little bit more time here. What
Um, okay. So we do this one. 2x squared, 2x squared minus 5x minus 3.
all right, very good. All right, so this is an a not equal to 1. This is a grouping problem. Okay. And in this case, you take that first number and multiply it by the last number here. All right. So 2 times -3 is -6. Okay, so you're looking for two numbers that multiply to -6, but add to -5. So go ahead and give that a shot, please. Multiply to -6, but add to -5.
Six, 3. Okay. Okay. It would be 2 and -3.
So 2 and -3 multiply to -6, but they do not add to -5. It adds to -1.
So they would both be negative.
Well, if they're both negative, they multiply to 6, not
Oh.
-6. So these are not correct. Okay, so when it's negative, that means one's positive, one's negative. You had that part right. -1 and 6, 1 and -6.
Okay, so this
-2
would,
and 3, 2 and -3.
okay. So then it would be -2 and 3.
It has to add to -5. Those don't add to none of these on the bottom here add. Like you're literally adding them up here. -2 plus 3 is 1. 2 plus -3 is -1.
Okay. Yeah, I don't.
How about the second one here?
Oh.
So we're gonna write 2x squared minus 6x plus 1x minus 3.
Mhm.
Okay, now we're gonna find the GCF of the first two. What goes into both 2x squared and 6x?
2.
2, anything else?
2x.
2x. So you're gonna divide both of those by 2x.
That would be x minus 3.
Good. And then you immediately write that over here and you try to figure out what goes here such that when you multiply in, you get back to the previous line. It's exactly the same as the previous line, so that's plus
1.
plus 1. So this becomes x minus 3 times 2x plus 1.
Mhm.
So go ahead and get that down. That'll probably take us to the end of our lesson for today.
Okay.